Hello everybody. Today we are going to start with a new chapter in standard 8th chemistry, that is language of chemistry. That is chapter number 5 from Viraf Dalal textbook. Now, the language of chemistry is the most important chapter of your 8th standard. The reason being that it is something like learning ABCD of chemistry. See, chemistry has got its own language. That means each and every element is given a specific symbol like the alphabet. Okay, so जैसे ABCD है वैसे यहाँ पे हाइड्रोजन के लिए H, हीलियम के लिए He, वैसे these are the different kinds of symbols which are given to each and every element. So these are the alphabets. The different names of the compounds or the name of the elements are the alphabets. When you combine the alphabets together, you got the like what you have the 2-letter words and 3-letter words. Similarly, यहाँ पे भी you're going to have the compounds which will be formation of 2 elements together or 3 elements together. So in that way, in that form, you are going to form a compound, and then these compounds are going to be used in a sentence, which is nothing but the chemical equation. So the chemical equation is nothing but the sentence of a chemistry. So that's why language of chemistry is very important, because if you do not know the proper things about the language of chemistry, then understanding chemistry or writing any equation or writing any particular name of a compound will be absolutely very difficult. So that's why it is very important that you concentrate very well in this particular chapter of language of chemistry. So introduction wise, we very well know what is matter. So matter is anything that occupies space, has mass and can be perceived by our senses. Matter, that is substance, may be pure or impure in nature. Pure substances are further classified as elements and compounds. So we had learned this in the earlier chapters. The matter का तो chapter था, elements and compounds का दूसरा chapter था. So we know very well that matter is something which is going to occupy space, will be having mass and can be perceived by our senses. So that's why we say that air is also a matter. Also, matter is made up of 2 kinds of substances, like it could be a pure substance or an impure substance. When you talk about the pure substance, there are 2 kinds. One is the element, which is having only 1 kind of atoms present in it, and it will be a compound which will be having 2 or more kinds of atoms combined together to form a molecule. So element is a pure substance made up of 1 kind of atoms only. It cannot be converted or broken down into 2 or more simpler substances by any physical or chemical means. So it is not possible to divide an element into simpler substances. Element by itself is a complete substance which cannot be broken down further into any particular kind of substances. Yeah, of course, we talk about the atoms, it is divided into protons, electrons, neutrons, but that is not a substance, okay? When you talk about substance, when we talk about elements, elements are the one which are the pure substances which cannot be broken down into 2 or simpler substances. So atom, it is the basic unit of an element which may or may not exist on its own. An atom of an element is denoted by a symbol. So atom is basically a particular kind of a smallest particle of that of a substance which can be having the properties of the substance. So that's why we say that it's a basic unit of element. So when we say that it's a smallest substance, the smallest unit of matter which is going to be having its own properties is nothing but the atom. The atoms may or may not exist freely in nature, okay? Atoms, if they are able to, if the substance is such that it can be available in a single atomic form, then yes, it will be available freely in nature. But most of the elements are such that they cannot exist in a single atomic form. That's why they need to combine together to form into a molecule, and only then they can exist freely in nature. That's why we have written over here that atom, it is a basic unit of element and which may or may not exist on its own, When you say on its own means they cannot exist freely, they are going to be existing either in a combined form with a similar atom of their own, or it could be combining with some another kind of elements which is forming into a new substance or a compound. So, and all these atoms are represented by symbols. Now these are the symbols which are the ABCD of the chemistry. So chemistry ka ABCD is nothing but the symbols which we are using for the different elements or the different atoms of the different elements. So that is about the introduction of the chapter. Now we are going to see that the symbol. When we say about the symbol, तो symbol ऐसा तो है नहीं कि जहाँ पहले से उन्होंने decide कर दिया था कि हाइड्रोजन को H बोलेंगे और नाइट्रोजन को N बोलेंगे. No, it never happened that way. It went into phases. There were so many different phases which went through, and after which it was decided that okay, this is the right method to be used for the naming of a symbolically mentioning about a particular element. So in this case, in fact, just to go out of this chapter, we can just say that when you talk about language of chemistry, it can also be seen that in olden days, each and every scientist, okay, they were comfortable to give the name of a compound or a element which is their native language. Okay, so a person who will be in say Greece, or he will in Rome, he will be giving it a Greek name, but those countries who were the the English companies, they will be giving the names in the English language. So accordingly, it used to happen that the same particular substance was named differently by different countries, and that's why when it came to the what we call it as a general meeting of the scientists together, at that time it was found that it was very uncomfortable for people to exactly identify what exactly the other person was talking about, or what particular element he was talking about. Like for example, if I talk about sodium, I know that sodium, which we call it in English, it is called as natrium in Greek. So, and this is more prominently known. So people who were English the scientists who were English scientists, they always found it very difficult to understand. किसी ने बोला natrium does this. Okay, you cannot understand what do you mean because you don't know the context. कि natrium and nothing but sodium. So then it was always this particular kind of a problem. So it was also necessary that the symbols, if they are made, they will help identify the substances more easily because symbols will be universal. Like simple example over here, it's again sodium is starting from S and O, but the sodium ka jo symbol hai, it is Na. Na is sodium, right? Potassium ka symbol is K. Why? It is because it's kalium. Okay. Now why is it so? This is because when they tried to find out, they found that the substances like sodium and potassium and all, they were much more famous by their Greek names rather than the English names, and that is why the symbols were made accordingly. So once the symbol was determined that the symbol should be like Na for sodium or K for potassium, it was very easy for any person of any language or any country to identify, अच्छा okay, he is using Na for this thing. अभी Na वो sodium बोले या उसके language में जिसको जो बोलना है बोले, it will be easier for the scientist to understand, or any particular person, why not only scientist, any particular person to understand that what exactly is the ingredient of that particular compound. So this was one of the major reason to have a symbol. So the symbol was required not only for understanding the thing but also for having a clear idea between two countries about a substance which is present in the compound. Secondly, it was also required because these particular things also, like if I'm going to write over here, like if I write that hydrogen plus oxygen is going to give me water. Now this particular equation, right, when I'm writing this thing, is quite lengthy process. So that's why it was always better to write it in a shorter form so that I don't need to write it like ये hydrogen तो फिर छोटा है. इधर क्या होता है? You are going to write the name as potassium sulfate or calcium chloride or calcium hypochlorite. तो इतने सारे बड़े-बड़े नाम लिख के उसके बदले you are having a short 3-letter, 4-letter alphabets over there. It will be easier for you to write that equation. So that's the reason. It was easier if I am having a symbol, so H2 plus O2 giving me 2H2O. So this is an easier method of representing a particular equation rather than writing as hydrogen plus oxygen give me water, right? So that's the two main reasons why the symbols were required for the chemistry. So let's see what is written here. That symbol is a short form of or abbreviated name of the element. So symbol is the abbreviation or the shorter form of the element. It represents a specific element or one atom of an element. For example, H represents one atom or of element hydrogen. So when I say H, it means that I am talking about one atom of hydrogen. So that's why the simple representation of a particular element by a simple alphabet is going to be called as a symbol. It also represents the weight of the element equal to its atomic weight, and it distinguishes one element from another and is characteristics of that element only. So yeah, it also represents the weight of the element equal to its atomic weight. So when I say hydrogen, okay, fine, uska matlab hai atomic mass 1. Okay, when I say about sodium, I know, okay, atomic weight 23. So accordingly, when I talk about any particular kind of a substance as a symbol, it is associated with its atomic weight also, it is associated with the properties also, and further the characteristics of the element are also known to you. So accordingly, the symbol is going to a small symbol like Na is, okay, telling you about sodium. Now you know sodium, sodium तो फिर सब कुछ मालूम है कि sodium क्या है. तो it's easier to understand or write about that particular element. Now initially it was given this way. See, in the start, when the elements were not discovered much, at that time there were hardly around 16 elements, known elements in the nature. So they never knew that air was not an okay, air to फिर भी पता था उन लोगों को, but there were many other cases wherein they didn't knew that it was an element. They thought that it was compound. They never knew that it was a compound. They thought that it was just an element. So later on, they came to know that, okay, these are made by different elements. Like for example, if you take about air also, we know initially air was considered to be just a single element by itself. They never had any kind of bifurcations, or they never knew that it was made up of this much percent of nitrogen and oxygen and all. So they were just considered. But then they slowly and steadily discovered so many different things, and now you know that, okay, there is a mixture of so many different gases. So initially, the number of elements which were discovered were very less, and that's why John Dalton, you remember John Dalton, the same person who gave the atomic theory. So John Dalton's atomic theory, वही John Dalton ने, he preferred that let us name, or we can say that we will use some kind of a symbol for representing a particular element. So like for example, for nitrogen, we can have a circle with a line in between. Okay. For hydrogen, we can have a circle with a dot inside. So if I want to say NH3, it means I'll be writing over here N and then H here, H here and H here. So this is nothing but NH3. That is ammonia. This was perfectly fine for everybody at that time because there were only 16 such symbols to be remembered. ऑक्सीजन के लिए सिर्फ सर्कल, सल्फर के लिए एस के अंदर एस करके डाला रहेगा, या किसी के अंदर कुछ क्रॉस डाला है, इसके अंदर ये है तो किसी के अंदर ऐसे करके क्रॉस है, किसी के अंदर ऐसे करके कोई मे बी सम प्लस साइन है. So there would be some or the other kind of symbol which were made, and this figurative kind of the symbols did not work because as and when the new substances or new elements were being processed or when they got discovered, it was then difficult to identify each and every of them. And that's the reason, and to make such different things, इसके square डालेंगे तो comfortable नहीं था, तो इसलिए figurative kind of a symbol was discarded, which was proposed by John Dalton. So that's why John Dalton suggested figurative symbols for atoms of elements. Like nitrogen will be given as a circle with a standing line. So ammonia will be standing line, and then three hydrogens over here. But it was in 1814 that Berzelius suggested a simple approach for representing the elements. So it was decided that नहीं ये circle बर्कल वो सब नहीं चाहिए, उसके बदले what we'll do is that we will have a very simple approach towards writing the symbols of the elements. So what was that approach? So the approach was a very simple kind of a thing, that the one sec, I just it was quite easily given that all the elements which are very prominently used, which are like day in and day out used, like nitrogen, oxygen, hydrogen, carbon, all these which are in abundant use, they will be the one which will be given the symbol which is the first alphabet of that particular name. So that's why you have got oxygen given by the letter O, hydrogen given by the letter H, nitrogen given by the letter N. Now, so the first letter of the name of an element was taken as a symbol of the element. So carbon or C, method not approved since two elements can have the same first letter. So now the problem was that okay, ये तो ठीक है, but the problem is that what will happen? Suppose I say till now that carbon is C, but what about calcium? What will I do about calcium? Calcium को भी C में नहीं ले सकते. So then it was decided that those जिसमें first alphabet already use हो चुका है, we will take the first two alphabets or the first alphabet and the most prominent alphabet. Like why prominent alphabet? So this is like calcium के लिए Ca, but chlorine, now chlorine में H is silent, so that's why you are taking it as Cl. Okay. Similarly, if I am taking magnesium, and manganese. So here mag is common, so it is Mg, and manganese, so it is Mn. So this way you are going to have the first two letters of the names of the element was taken as a symbol. So calcium Ca, method approved since many symbols could be written accordingly. And then one more thing was that, so accordingly what will happen is that you are going to take the first maximum लोगों का ऐसा maximum elements का योग, the first alphabet is the name. Second condition was that the first and the first two alphabets or the first and the most prominent alphabet you are going to take as a symbol of the element. But in certain cases it was found that the compounds were such that they were more prominently known in the Latin names or the Greek names. So the Latin names, जहाँ पे Latin names were very prominent or very, like for example, the copper, what we say is very means world over ज़्यादा करके famous है in the name of cuprum. So cuprum is more famous than copper, and that is why instead of CO it is given as Cu, cuprum. Same thing is for sodium. Sodium से ज़्यादा natrium is more famous, so it is Na. Potassium is scandium, that's why K. Okay, gold is aurum, that is Au. So in this way, the one which were the Latin names of the elements was taken and the symbol derived from the Latin names, like for example Cu for cuprum, method widely approved and used. So this was widely approved and used because most of the people in the world were at that time using the word natrium or cuprum or ferrous. No, ferrous. The ferrum. Ferrum is also, ferrum is nothing but iron. Iron is also, iron is not so was not so prominent at that time. Ferrum and ferrous and ferric are more prominent at this time. That's the reason it was decided that certain names or certain symbols be derived from their Latin names rather than the English names. So instead of using the English names, they use the Latin names. In certain cases also Greek names were used for taking the symbols. So this is how the symbols were generated. So the symbols for the different elements were formed by taking into consideration the following rules. So the rules were, the first one, the first alphabet of the element, which was not easily approved because there were so many different names which were starting with the same alphabet. So that's why they said that okay, then first and the second, or the first and the most prominent alphabet which is going to be there in the name will be taken up as the symbol. And also the third option was to take the Latin names or the Greek names. So Latin name, mainly Latin. So most of the things which are there are Latin names. So Latin names were taken up instead of the English names for the formation of the symbol. So that was about the symbols. So what we understood by now is the ABCD of the chemistry. So what is the symbols? The symbols of the elements are nothing but the ABCD of chemistry. Now once you know the ABCD of chemistry, we are now going to make words of chemistry. What are the words of chemistry? They are nothing but the compounds of chemistry. The chemical compounds which are going to be formed, they are going to be called as, we can say it as the words of chemistry. Now before we understand the words of chemistry, or before we try to understand that how to frame the words of chemistry, we need to know a very important property of an element which will help us to identify that how the compound formation will take place. And that important thing over here is the valency. Valency. You have studied this. When did you study it? In atomic structure. What is the valency? Outermost orbit. Yes, that's right. The outermost orbit के अंदर जितने electrons थे, they were the valence electrons. And to complete their outermost orbit to 8 electrons, either by donating it or accepting some electrons. So the number of electrons which it is going to accept or donate or share to complete its electronic configuration is the valency. So if we want to define valency, electrons के बदले what we will be calling it will be hydrogen atoms, because hydrogen is going to be one electron in it. So अगर if one particular element is going to react with 2 hydrogen atoms to form a stable compound, its valency is 2. If it requires 4, then its valency is 4. If it requires 1, then its valency is 1. So number of hydrogen atoms with which that particular compound is going to react to complete its electronic configuration, its outermost orbit, can be said to be as the valency of that element. So let's see this. Valency is the number of hydrogen atoms which can combine or displace one atom of an element or radical, forming a compound. So it is that number of hydrogen atoms. If the number of hydrogen atoms which are going to be used in a compound to formation of a compound could be 1, then the radical or the atom which is already there is having the valency 1. If it requires 2 hydrogen atoms, it will be 2. Like for example, for formation of water, see, let's see a very simple thing. It's H2O. So O required 2 hydrogen atoms to complete this thing. That's why what is the valency of oxygen? Oxygen valency is 2. You very well know this thing. Why valency is 2? Because the electronic configuration is 2, 6. The electronic configuration of oxygen is 2, 6. So how many electrons is it required to complete its outermost orbit to 8? 2. That's why we are having 2 hydrogen atoms. Got it? We require 2 hydrogen atoms. Similarly, like see, if I say HCl. So Cl के कितना hydrogen लगा? Only 1 लगा. That means what is the chlorine का valency? It's 1. And you know very well, it is 2, 8, 7. So how much does it require? Only 1. So in this way, the valency is very, very important for an element. Okay, because it will determine how many number of hydrogen atoms can it be reacting with to either accept, donate or share with each other. So hydrogen chloride HCl, 1 atom of hydrogen combines with 1 atom of chlorine. Valency of chlorine is 1. Water H2O, 2 atoms of hydrogen combined with 1 atom of oxygen. So valency of oxygen is 2. Ammonia NH3. So NH3, H3, that means valency of nitrogen is 3, 2, 5. Remember that. So 3 atoms of hydrogen combined with 1 atom of nitrogen. Valency of nitrogen is 3. So the valency of some elements which do not combine with hydrogen then becomes the combining power of the element with an element whose valency is known. So suppose, like for example, if I am talking about zinc. Now zinc doesn't react with hydrogen directly to form any kind of a zinc hydride or something. So because I do not know that how will zinc be reacting, so what will happen? If I am forming a compound, so I know that zinc will require 1 oxygen to stabilize it. ऑक्सीजन का वैलेंसी मुझे ऑलरेडी इधर मालूम है कि ये 2 है, so automatically zinc का वैलेंसी is also 2. So whatever is the combining part, okay, like for example NaCl, let's see about NaCl. We don't know about NaCl now, but I know that Cl का वैलेंसी 1 है, तो Na का भी वैलेंसी क्या होगा? 1 ही होगा. Okay, so valency of some elements which do not combine with hydrogen then becomes the combining power of the element with an element whose valency is known. So here I know the valency of oxygen, so it will be combining power of oxygen के साथ में है, तो automatically it will be 2. Combining power chlorine मुझे मालूम है, तो accordingly it will be 1. So zinc combined with oxygen forming zinc oxide ZnO. Valency of oxygen is 2, hence valency of zinc is 2. Are you understood this thing? This is basically you should know the valency of basic the elements which are going to combine with hydrogen. Once you know the valency of that particular combining atom, then that combining atom का जो भी valency रहेगा, that will be the valency of the other element which is being used. Anyway, we'll discuss this much more when we are talking about the positive and negative valencies on the next page. Points to note: the valency of all metals is considered to be positive, that is Na plus, and the non-metals is negative, that is Cl minus. So here you can see that whenever you are going to have a compound which is going to be a combination of a metal and a non-metal, metals are always going to be taken as plus valency. Now this you know very well is because valency, like for example the sodium over here is 2, 8, 1. So this one is going to be given away. Because it is going to be given away, that's why it is an extra over here, that's why it is plus 1 valency. Chlorine on the other hand, it is going to accept this thing, so it will be, that's why it is minus 1. That's why the valency of all the metals will be positive and the valency of all the non-metals will be taken as negative. Okay, metals, because they are the donors of electrons, that's why it will be a positive kind of a valency, and because the valency of the non-metals are going to be negative in nature because they are going to accept electrons. They are lacking electrons, they are going to accept electrons from others, or they are going to share the electrons with others, and that's the reason they are given as a negative valency. So valency of one element are said to be so if now talking about the valency, the valency could be 1, like for example in case of sodium the valency is just 1. So these elements which has got only one valency, they are called as monovalent. So valency 1 elements are said to be monovalent, Na plus. 2 are said to be as divalent like Zn2 plus, and 3 are said to be trivalent as aluminium, that is Al3 plus. So if the valency is 1, it is monovalent. If the valency is 2, it is divalent. If valency is 3, it is trivalent. Valency is also the number of electrons an atom can donate or accept. So, okay, valency is also the number of electrons that the atom can accept or donate. I told you earlier also that the number of electrons which can be donated or accepted or shared, okay, it will be valency is also the number of electrons an atom can donate or accept so as to achieve a stable electronic configuration of the nearest noble gas. So sodium, when it is giving away 1 electron, it becomes 2,8, which is equal to neon. So electronic configuration of neon will be 2,8, where sodium भी अगर अपना 1 electron दे देगा, so it will also have this electronic configuration similar to neon, and in such a case the 1 plus which is there will be the valency of the of sodium. So that was about the valency. Now valency is also, okay, I'll just continue in the next video.